Welcome to another very exciting episode of the Flip Classroom. Welcome. Today it's Algebra 1, Lesson 13, Calculating and Comparing Square Roots. You know how to do square roots? Do you know where the button is for square roots on your calculadora? Gracias, sí, señor. Muy bueno. Yeah, okay. So if you don't know about these green and blue buttons here, the blue button allows you access to all the blue things on the number pad here. And so we're going to use the blue button second and to go down the side, and you're going to find that in the white it says x squared, and in the blue it has the square root. And if you do that second and that thing, it pulls this up. You've seen that, right? You can do that? Okay, sometimes there's just a button for that. This one does a clever thing and puts the square and the square root right next to each other. If I type in the square root of 64, I get 8. And if I square 8, I get 64. That just means that these two things are related to one another. They are very similar there in a sense. Inverse operations like add, subtract, multiply, divide, square, square root. Got it? Okay, that's it. No, just kidding. All right, let's talk about some vocabulary. I'm going to talk you through these things here with some examples. And the first is we need a list of perfect squares. Okay, you need to have your notebook, and you need in the back somewhere, if there's not already something like it for you, to list squares of numbers all the way up to like 20. Good. Now they oftentimes have multiplication tables in them. All the squares go diagonally from top to bottom here. 1 times 1, 2 times 2, 3 times 3, 4 times 4, all the way down to the corner has 12 times 12. We're going to need more than that. We're going to need more than that. This is what you need to do in your notebook. You can say perfect squares. You can say 1 squared equals 1, 2 squared equals 4, 3 squared equals 9, and go all the way down until you're doing 17 squared, 18 squared, 19 squared, and 20 squared equals 400. This one equals, I think that's right, 381. I think. Double check that. That feels right, doesn't it? 19 squared. Nope, 61. Didn't feel right. 18 squared is 296. Nope. 324. 17 squared. Should just be using my mental math at this point. Okay. You're probably pretty familiar with everything up to 12 by 12. 13 by 13 is 169. 14 gets us up to 196. 15 is easy one, 225, and then on up. But okay, go back and review your 1 through 12s, but then work at these ones down here all the way down to 20 times 20, so that when you see those numbers, you're like, wait, is that on my list of perfect squares? The name perfect squares comes from what the geometer would do, and that is, look at the word, square. They make a square, okay? And a square is defined as an object that's got 4 right angles and 4 equal sides. So the area of that square is really what we're looking for, because a square that is a 1 by 1 square has an area of 1. And by just means multiply. By means multiply. This one has dimensions of 2 by 2, and there are 1, 2, 3, 4 square units there. You see where we're going with this? 3 by 3 has 9. 4 by 4 has 16. Those are perfect squares. And what square rooting does is it says, if that's the area, what's the length of the side? And the sides are the same. So we're basically like pulling that apart and seeing where did the square come from? It came from an object that has a side of this length right here. So we need our list of perfect squares because if it's not a perfect square, what we need to know is how close to a whole number is its square root. Okay, so you can do a little bit estimating, a little thinking. So you're going to thinking cap out. All right, next thing is Radicand. And Radicand is just that funny check mark symbol thing. And that underneath that is where the root thing goes. I believe that's the way it works. Okay, that's just, what are we going to call it? The radicand is actually the number or the expression that's underneath what is called the radical symbol. So the radicand, that'll be right here. And when you type it up on your calculator, it's the thing in the little dotted box. That's what the radicand is. So if we took the square root of 64, 64 is the radicand, and the jiggly line is the radical, and then we'll get our solution there of 8. So squaring and taking a square root are inverse operations, the same way that if you start with something and you add 5 and then you subtract 5, you get back where you started from. So if we take the number 3 and we square it, we get 9. If we take the square root of that, we're back to 3. Okay? Get how that works? Some people just really can't grab that for a while, but there we go. Now, if we don't have a perfect square, if we have something like the square root of 10, we do kind of want to know what that is close to. We want to have a good estimate. That's like, well, it's got to be at least 3 because 9 is a perfect square, and square root of 9 is 3. So it's going to have to be a little bit bigger than 3, but it's not 4 yet because 16, square root of 16 is 4. So the book will usually say between what two whole numbers. I want you to estimate that. You'd say between 3 and 4. It's closer to 3 than it is to 4. There's some fun ways of estimating that to numbers of digits and whatnot, but or fractionally. But that's what they're looking for. They're looking for you to put on your thinking cap and say, well, I got a list of perfect squares, so let me just find the ones where the radicand is between those two, and I'll work my way back to the smaller number there, the 2 or the 3, and see what I get. So, for instance, let's look here, and I'll give you, 350, square root of 350. And you're like, oh, I don't know. But what we do know is that 350 is between 324 and 361. It's probably a little closer to 361. But in general, just the next closest two whole numbers, we took the square roots, it would be somewhere between 18 and 19. Okay? That's how those work. They're going to ask you to do some estimating to the nearest two whole numbers. Which two numbers does it get sandwiched by? Righto. Okay, last thing is with comparing. They're going to give you some little mini problems to do, and then they're going to put this little circle in the middle, and you're going to say, is it bigger than, is it less than, is it equal to, and they'll give you something like this. Okay. Here's what you don't do. Do not do this. Well, that's the square root of 40, and this is the square root of 34. So that's bigger. It may be bigger, but that is not the square root of 40, and that is not the square root of 34. You can do it on a calculator. You can see that those two things are not, that's not what they're equal to. What we've got over here is a perfect square and another perfect square. So there's like nothing else you need to do except to go, that's 2 and that's 6. So this side equals 8. Don't get like create it. Okay? No one to say no. And over here, we're like, well, that's 3 and that's 5. And so that's also 8. You can see here that these are equal to. And if we were trying to do this kind of business, we'd have to say that that was true. But it's not. But it's not. Okay? You're not allowed to just add stuff that's in under separate thingamabobbers. When we get to multiplication, well, there's a different story. But for here, that's not what happens. That is not it. This is a little problem, solve it. That's a little problem, solve it. And so if you know what your perfect squares are, you know you can do something right there. You don't have to think, well, how do I fix this? You don't have to fix it. It's already a perfect square. Just solve the thing. I mean, for crying out loud. I mean, please, I'm asking you, I'm begging you, just do that. But you have to be familiar with those numbers. They've got to be your friends, okay? Friends are there for you. They are there to help. Last thing, application would be this type of thing. How many square feet? And then boiling it back down to what's the length of a side. So if they give you a problem, they say something has a square footage of 361 square feet. And they ask you, well, what's the length of one side of that room? Maybe we'll do it like this. We'll call it foot squared. This is cool. I take the square root of feet squared and I get feet. Because squaring and square rooting are inverse operations. So I'm going to have units in feet. 361, I know that's a perfect square because I had to look it up, didn't I? 19 by 19 will give you 361. So the moral of the story is get to know those perfect squares. And then working backwards toward the root of those things is just undoing something. A problem like that, you're undoing the area problem back down to a single dimension type of problem. It's all based on the fact that a square has equal sides and equal angles and 90 degrees. That's only how that thing's going to work geometrically. Algebraically, it's that number times itself and then undoing that operation, going back and finding what the original number happened to be. Okay? Only way you can estimate is to know if it's above or below a certain number. You're going to need that list, your calculator, your thinking cap. I know you can do it. I believe that you might be able to on your own. Now, I'm not saying like you're going to get 100% or anything, but if you work hard, you can do better than 0. That's my advice for you.